2-3, linear functions in slope-intercept form. So in this section, we're going to introduce lines, basic lines, and we're going to talk about the most common type of equation, which is a slope-intercept form of a linear equation. Okay? So our objective is to graph linear equations and to write equations of lines. So what you should know by the end of this section is we should consider a non-vertical line in the coordinate plane. Okay? And if you move from any point on that line to any other point on that line, the ratio of vertical change to horizontal change is constant. And that ratio is called the slope. So what we're going to look at is we're going to look at a line, right? And we're going to have a non-vertical line, right? And we're going to have these 2 points. And as we move from one point to the other point, right, we're going to talk about that ratio, okay? And that ratio is, of course, called the slope of the line, okay? So the slope of this non-vertical line is the ratio of the vertical change to the horizontal change between 2 points. Like, for instance, between this point right here and this point right here, x1, y1, x2, y2. And you can see that my vertical change is here in the red, and my horizontal change is here in the blue, okay? And when we talk about this, when we talk about our slope, we want to calculate the ratio between those two. And we can calculate it by finding the difference in the y coordinates over the difference in the x coordinates for any 2 points on this line. So if we knew this difference right here, if we knew this difference, this vertical change, and if we knew this horizontal change and we divided the two by each other, we would have the slope. And here's my formula for that. The slope is equal to rise over run, right? The slope of a non-vertical line through points x1, y1, x2, y2 is the ratio of vertical change to the corresponding horizontal change. So we have rise over run, okay? Vertical change over horizontal change. y2 minus y1 over x2 minus x1. And most commonly, this is referred to as, what is referred to as slope, and we would use the abbreviation M most often, especially when we get to slope-intercept form in a few minutes. Okay? So let's practice finding the slope. What's the slope that passes through these 2 points right here? Okay, so looking back at the formula, right, we take y2 minus y1 over x2 minus x1. So we're going to do y2 minus y1 over x2 minus x1. Plugging in my numbers. Now, I can start with this y or this y. I can call either one of those y2. It doesn't matter, as long as you take the x from the same point. Let me show you what I mean. Okay, let's call this point right here y2. So this would be x2. So we're going to take 4 minus 7 over negative 2 minus negative 3. 4 minus 7 gives me negative 3 over 2 minus a negative 3, that's a plus 3, gives me a 1. So my slope here would be negative 3. Now if I wanted to, I could switch these two around. I could call this y2 and this y1. But if I call 7 y2, I have to be sure that that is x2. So let's do it over again. Let's start now. Instead of starting with 4, let's start with 7. So 7 minus 4 over negative 3 minus negative 2. So this would be a positive 3 over a negative 1, which is still negative 3. So in both cases, I got the same answer. I got the same slope, which is good. That's what I want. But I have to be sure that I don't call this y1 and this point, or sorry, 7 y2 and this point x2. So what do I mean? Don't do this. Don't do 7 minus 4 over negative 2 minus negative 3. In that case, I started with the 7. I started here, but my first x coordinate was over here. Okay, that's sort of what you don't want to do. So let's get rid of that. Okay, as long as you start with the same point each time, you'll be fine. Let's take a look at another one. Okay, so in this case, let's start with y minus what? y1, let's start here. y2 minus y1. 1 minus 1 over, and let's start with 3 minus 4. In this case, it doesn't matter because both y's are 1. So we have 3 minus negative 4. Okay? So now, when we plug these in, we get 0 over 7. Okay? When I take 0 divided by anything, my slope here is 0. Okay? That is an acceptable slope. It's okay to get a slope of 0. Here, however, when we look at this problem, okay, when we start with y2 minus y1, negative 3 minus 1 over 7 minus 7, now we have negative 4 over 0. In this case, we all should remember that you cannot divide by 0, so in this case, there is no slope, okay? My slope is undefined because dividing by 0 is undefined. Okay? And if I look at another one, right, if I look at this problem right here that we did in class, we would take 6 minus 0 divided by 2 minus 2, which would give me an undefined slope, right? 6 minus 0, y2 minus y1 over 2 minus 2. Okay, so that would be an undefined slope. Okay, our slopes can also tell us what the line is going to look like. For instance, if I have a positive slope, okay, that line is going to be going up as I look from left to right. Okay, as I read from left to right, this line has an upward slope. With a negative slope right here, this line is going down from left to right. So as I look at the negative slope, it falls from left to right. This line rises from left to right. This one falls from left to right. Something with a 0 slope has no slope, right? It doesn't go up and down. It's a horizontal line. And then my undefined slope is a vertical line, okay? Something that is straight up and down. And as we come to understand slope a little bit more, we should realize that a slope is a measure of steepness. So something with a positive slope of 1, which is just like this line right here, is not going to be as steep as something with a positive slope of 2, which would look something like this. Okay? So as the slope goes up higher and higher, the steepness of the line is going to get bigger and bigger and bigger and bigger until we get to something that is undefined, that is so steep it has no slope. Okay? And then same thing as it gets smaller and smaller and smaller and turn into a fraction, like something with a slope of 1/2 would look something like this. Okay? As it gets flatter and flatter and flatter and flatter, as the slope gets smaller and smaller and smaller, we would get something that looked like this, that would have 0 slope. Okay? So just looking at the number and slope, comparing it to another line, you would be able to tell which one is steeper compared to the other one. Okay? So, right, now let's get into lines. So a function whose graph is a line is called a linear function. Okay, this is just any function whose graph is a line. And we can represent a linear function using a linear equation, like y is equal to 6x minus 4. Right? And the solution, the ordered pair that we can plug in to that equation, x comma y, is something that would make that equation true. Right? And that would be the solution to this particular linear equation. Right? As we talk about linear equations, one of the most common ones is called slope-intercept form of a linear equation. Right? But in order to know what that is, we have to remember what an intercept is. An intercept is a line. An intercept of a line is a point where the line crosses the x or crosses any axis. The y-intercept is where we cross the y-axis. The x-intercept is where we cross the x-axis. Looking at the picture, this point right here would be the y-intercept. This point right here would be the x-intercept, okay? Because this point is the point where, that's where the point where it crosses the y-axis, and here we have the point where it crosses the x-axis. In slope-intercept form, we're concerned with primarily the y-intercept. So slope-intercept form, okay, is this equation. Y is equal to mx plus b, where m is the slope and 0 comma b is the y-intercept. So that means that that point right there, whatever number b is going to be my y-intercept. And whatever is in front of the x value is going to be my slope. So, looking at an equation, we should be able to write the equation of the line given certain things. Here we're given the slope and we're given the y-intercept. So I can look back at my equation right here and say, okay, y is equal to mx plus b, slope times x plus the y-intercept. So y here would be equal to slope times x plus the y-intercept, which is -3, so we would have a -3 there. And that's my equation in slope-intercept form. This question doesn't specify what form, so I'm going to keep it easy. I'm going to keep it in slope-intercept form. I can do this if I had a slope and an intercept. I can also do it if I just had a picture. Okay? From this picture, I can figure out the slope, and I can figure out the y-intercept. Well, that point right there, my y-intercept is going to be 0 comma 4. Okay? My slope, m, if I remember, it's going to be rise over run. Okay? So I can see that this line goes, it goes 1, 2, 3, 4, goes down 4. So my rise is going to be -4 over my run, which is over right 1. So it's going to be -4 over 1, which is going to, 1, 2, 3. Down 3 over 1. Okay, so it's going to be -3 over 1. Sorry about that. So we have our slope of -3. Okay, so now that I have my intercept and my slope, I can now write an equation. So y would be equal to -3x plus 4. Okay, so -3x plus 4. Okay. With a problem like this, okay, we'll get to more of how to change a slope-intercept into a different form. But here I see my slope, I see my intercept. I can write this as y is equal to -1x or -x plus 3. All right, I don't see that answer anywhere, but if I add x to both sides, I would get that answer right there. Okay. Okay. And that brings us to something that we'll do. That question brings us to the fact that we can rewrite linear equations in slope-intercept form by solving for y. So we can go the other way. Instead of taking slope-intercept form and moving it to a different form, we can start with a different form. This is actually standard form right here. We can start with something that's in a different form and turn it into slope-intercept form. And then the question asks us, what are the slope and the intercept? So in this case, I'm going to start by solving for y. So the easiest way to do that is to subtract 5x from both sides. That would give me -4y is equal to -5x plus 16. Now, to get y by itself, I'm going to divide by -4, realizing that I have to divide everything on the right-hand side by -4. Those two cancel, and I will have y is equal to -5 over -4 turns into +5. Negative over negative is positive. +5 over 4x, and 16 over 4 is going to be -4. Okay, so that means my slope is going to be 5 over 4, and my y, my y-intercept is going to be equal to 0 comma -4. Okay? That is the point where the graph intersects the y-axis. Okay? I can do the same for this one, even though it has fractions in it. That's okay. Okay? So my first step is, of course, to get y by itself. So I'm going to add 3/4 x to both sides. That gives me 1/2 y is going to be equal to 3/4 x minus 1. Okay? Now, in order to clear out the 1/2, I'm going to multiply each side by 2. Okay? So that cancels that, and I have y is equal to 2 times 3/4 gives me 6/4 x minus 2 when I multiply the 1 by 2. But of course, I want to reduce that and simplify it into y is equal to 6 over 4 is 3 over 2x minus 2. And there's my equation in slope-intercept form, which means that the slope is going to be 3 over 2, and the y-intercept is going to be 0, negative 2. Okay. One more problem down here, right? The multiple choice problem, right? Here's my equation right here. Question asks us what are the, put it in slope-intercept form, and then what are the slope and the y-intercept? Well, same thing. Add 11x to both sides gives me 9y is equal to 11x minus 12. Divide both sides by 9. We would have y is equal to 11 over 9x minus 12 over 9 simplifies to 4 over 3, which makes the slope 11 over 9 and the intercept 0, negative 4, 3, which is C. Okay. The trick to this problem is also you could realize that the number in front of x is the slope, which means that this number and the slope must be the same. Those are not the same. Those are not the same. These are not the same. Okay? So you could pretty much eliminate all the answers before you even did the problem. Okay? Now, graphing. Okay? We know the equation of the line. We need to draw 2 points on the line. And so what do we want to do? We want to first write the equation in slope-intercept form. Then we want to plot the y-axis. Okay? Then we want to use the slope to find another point. And then we want to draw a point or draw a line through those points. So first things first, put it in slope-intercept form. Okay? Add 2x to both sides. That gives me y is equal to 2x plus 1. That's slope-intercept form. Okay? Here's my intercept point, plus 1. Let's put it on the graph. Right there. Okay? Now I'm going to use my slope of 2 to find the next point. This, right, means a slope of 2 over 1. That means rise 2 over 1. So we're going to go up 2 and over 1. Up 2 and over 1. Up 2 and over 1. I can put as many points as I need. I only have to do 2. We need 2 points to make a line. So let's see. Did I do everything we need to do? We wrote the equation in slope-intercept form. We plotted the y-intercept. We used the slope to find another point. Now, finally, we draw a line through the points. Okay? And there's my line. There's my graph of the line. Okay? Finally, okay? This problem was interesting because we didn't have, back in this problem, we had, if we're going to write slope-intercept form, we had a slope, right? We had a slope, and we had an intercept. Here, we had a graph. In this problem, all we have is 2 points. Now, we'll see a different way next lesson about how to write an equation of a line with 2 points using something called point-slope form. Okay? But here's my steps to write an equation in slope-intercept form using 2 points. First, find the slope of the line passing through the 2 points. Next, using either point, substitute it back into the formula. We're going to substitute x, y, and m into y equals mx plus b. Then we're going to solve for b. And then finally, we're going to write the equation in slope-intercept form. So how would we do that? Let's first find the slope. The slope is going to be equal to y2 minus y1 over x2 minus x1. So this is going to be 2 over 4, which is going to be equal to 1/2. Okay? Now, I can take either point. I can take this point or this point and substitute for x and y. If I pick the first point, x is 2, y is 5. If I pick the second point, x is 6, y is 7. Let's use the first point right here. So that would be 5. Well, my formula, y is equal to mx plus b. Okay, so that means 5 is going to be equal to my slope 1/2 times 2 plus b. These two multiply together and give me 1. So 5 is equal to 1 plus b. And subtract 1 from both sides to give me b is equal to 4. Okay. Now that I know b, I can substitute b and m back into my equation. Right? M would go here, b would go in there, and that would give me my equation. So we would put a general form for any x and y. Y is equal to 1/2 x plus 4. And that would be my equation in slope-intercept form using just 2 points. Okay. A couple multiple choice problems that we went through. We didn't get through all of them at the end of class, but I'll go through them all real quick. For that linear equation, which of the following has a value of 5? Well, figure out put the equation in slope-intercept form. So subtract 5x from both sides, you would get negative y is equal to negative 5x plus 2. Divide both sides or multiply both sides by negative 1, gives me 5x minus 2. So 5 would be the slope A. Okay. What's true about the lines that passes through those 2 points? Well, notice that the x values are the same. So that means it is going to have an undefined slope. Okay. So because it has an undefined slope, it is going to be vertical. Okay. If the y values were the same, it would be horizontal. Then it would have a 0 slope. What slope-intercept form of this equation? Well, get y by itself. Subtract 3x from both sides first. That would give me 2y is equal to negative 3x plus 1. Divide both sides by 2. So y is going to be negative 3 over 2x plus 1/2, which would be b. Okay. And what's the y-intercept of this graph? Again, put it in slope-intercept form. So subtract 5y from both sides. So we'd have negative 9y is equal to minus 5x plus 45. Divide both sides by negative 9. And so y would be equal to positive 5 over 9x minus 5. Okay. So my y-intercept would be right there, negative 5. 5 over 9 would be the slope. And the last question was, which of the following is the graph of that equation? 4x is equal to negative 1/2 y minus 1. Again, with all of these, put this into slope-intercept form. So add 1 to both sides. That gives me 4x plus 1 is equal to negative 1/2 y. Use the reflexive property to switch this around. Negative 1/2 y is equal to 4x plus 1. Okay? And then I want to multiply everything by negative 2, which will cancel this, give me y. Negative 2 times 4x is minus 8x minus 2. Now, this tells me my slope is negative, which rules out this one and this one, because both of those lines go up from left to right. This tells me that my y-intercept is negative 2. This intercept is positive 2. So that one's out. So even if you couldn't see exactly which points are where, we can see that this has an intercept of -2, a slope of 1, 2, a slope of -8, and my answer is going to be C. And that's the end of section 2-3, linear functions and slope intercept form.